Pythagoras Theorem is to mathematics what E equals mc square is to physics. That is, it is a single most popular theorem that everyone has heard at least once. But most can't appreciate its beauty because they just don't understand why it's true. Even if you don't know why it's true, I bet you wouldn't have seen a proof as beautiful as this one. So, get ready to square your eyes and ears so the sum can blow the square of your mind away. Let's just talk about triangles for a minute. This is a triangle, a very simple shape, just 3 points joined by a line segment. But there are some features about triangles we need to know. Let's start with its area. Well, if you take this triangle, rotate it and add a new replica next to it, it forms a rectangle. Area of this rectangle is just the base times the height. Now, let's take the half we added. What are we left with? Just half the original area, making the area of this triangle be equal to half times the base times the height. But this is a very spatial triangle. How about something more generic, something like this? What is its area? Well, if you can think it through, it would have been simpler if we could get a right angle triangle instead. What if we could? Let's cut this one triangle so that we get 2 right angle triangles. Now, using the same method, we can say that the area of the left triangle is half base 1 times height, and similarly, the area of the second triangle is half base 2 times height, making the total be equal to half base 1 plus base 2 times the height. So the total still is half base times the height. Almost magic. But did you see you could break any triangle into 2 right angle triangles? And as long as the height and the bases are the same, the areas will be equal. So this triangle and this triangle both have exactly the same area. That makes us realize that if you have 2 parallel lines and a triangle like that, and if you move or slide the third point around, the area remains the same. And for me at least, that feels almost spooky that it even works. Now, are you ready for the best Pythagoras Theorem proof on the planet? Take this triangle. This is a simple right angle triangle. Call this side A, B, and C. Let's draw A square, B square, and C square. Now, let's rotate it so it's just a bit easier to see. Ah, that's looking good. Now, cut this square in half, and if you see, these 2 lines are parallel lines. That means we can slide this third point around. Once we are there, and this is the craziest part, rotate it about this point as pivot. I know this can feel a bit crazy, so you can take a minute and pause and convince yourself that this will actually happen. Done? Great. Now we are here, and these 2 lines are parallel. So we can drag this point along here as well. And what do we have? Half of the area of this rectangle is equal to half of the area of the square. So the area of both the rectangle and the square is equal. Now let's do the same with the other side. Cut it in half. Because these 2 lines are parallel, drag it, then rotate and drag again. What do we have? Half of this rectangle and the half of the square above is equal. So both are also equal. Let's just add them up, and what do we get? The good old Pythagoras Theorem in all its glory. That's 1,000 times better than what I learned back in my middle school by dropping perpendiculars and finding similar triangles. I'm so happy right now because I just finished the editing of the video. And you know the craziest part is that just day before yesterday, I had opened up After Effects for the first time in my entire life. So do let me know what you think about the video. And the video that you saw, the proof, is by a guy named Euclid. And I had taken it from his book named as Elements of Geometry. And I've started a newsletter so I can communicate everything that I'm desperate about. Something like, consuming glucose can help you take better decisions because it sort of re-energizes your central nervous system. I'm not going inside the intricate details. So if you want to, you can go and search for overcoming ego depletion. You should find ample number of articles written on that. And yeah, if you don't want to do that, then you can subscribe to the newsletter wherein I will share not just about this, but everything that I find crazy that you definitely wouldn't find out anywhere else. And if you have made this far in the video, definitely you should subscribe because there is just no reason not to. Because really cool things, especially about how Germany was destroyed by Great Britain by a guy who sort of invented this bomb which can bounce on. See you then.
It's the same effect, yeah. Because the thing is spinning, you effectively get a bit of lift from it. So depending on in baseball, if the spin is on a vertical axis, it'll make the ball curve, and because this was on a horizontal axis, it effectively made it curve up the way, but it was falling under gravity, so the fall plus the curve upwards meant that it just didn't fall quite as fast as it would have done